Hey, good morning, guys. Good morning. It's good to see you. Oh, I like that, Nathan. You got the gas mask on. That's creative there.
Yeah, one of the filters is about to go because it's getting hard to breathe in here, so I'm gonna take it off.
Oh, all right, dude. All right. Well, hey, good morning, everybody. It's good to see you. Um, yeah. So we'll get today's class session going. And I apologize about the last minute add in there. Luke came in and let me know that my web link wasn't working. I'm not sure why it wasn't working, but we got another one up and running. A couple quick notes as we get started. Today, of course, this is the stuff here that we're going to be going over. We're going to have a fairly short lecture today, as I have a meeting that's supposed to start at 11. I'll probably get to it a little bit late, but I have to go to another new Zoom meeting with the administration. But this is the stuff we'll be getting into today. I did want to note down that since we are going to record today's lesson, remember that if you're on it or talking like Nathan was showing us his gas mask, remember that will be on the recording. So if you want to share stuff, remember you have to be okay with being on the recording there. Other than that, we'll get right into it. It's good to see you guys. I'm really happy to have you here. I hope everybody is well and healthy. And we have.
I think you would like this one too.
Okay, let's check that one out. Let's see here.
This is from Cold War era East Germany.
How do you have all these gas masks, Nathan? What's the deal with that?
I've been collecting them for a while now.
Why, Nathan? Just why?
In preparation for the virus, or this is
Thank
just
you.
some hobby or something?
The same question I was
I've had
asking.
this for years.
So kidding, Michael. So my friend Nathan, he has a bunch of gas masks he's been collecting. He's wearing one
Oh my
God,
goodness!
mute yourself.
a gas mask.
Yeah, I've had them for years.
All right, you guys. You're goofy. Let's go ahead and get going though. I also have the chat up as well. So remember to click that chat box and you can type things out as well. Today we are going to go into porting and stuff. Oh, before I do that, I do want you to know, and I'm going to type it on the screen here, that class is still on. Many of you guys who are enrolled in other automotive classes probably got an email that said, hey, we're canceling all the classes from the district, or maybe from your teacher, or from the administration. And basically what the Los Rios College District decided to do was cancel any classes that had lab in them if the teachers felt like, well, there was no way to finish the class. And so 90% of our automotive classes canceled, as well as welding and a lot of your other hands-on type courses. So with this class, because it was not part of our ASE accreditation, or NATEF they call that, because it's outside the box, I was able to negotiate that we could finish things up, because basically all the classes that get canceled, you guys as students, you will receive an excused withdrawal, or EW, on your transcripts, which that's not a negative thing, but essentially all the work you had done in your class up to that point, up till the end of March, was basically for nothing, right? You have no credit for completing anything. So it doesn't count against you, but you don't have anything to show for it. So for you guys that are continuing on in AT325, you're going to get full credit for the class. Now, what are we going to do about lab? Well, for lab, I'm going to, when we get back in the fall, I'm going to look at running a special section of skill and speed, which is the AT140 class. We also have AT225, which is a special projects class that we can use to basically give you lab time. So you figure out, hey, what do I want to play around with? Maybe I want to do some more stuff on the dyno or whatever. We'll have some options for you to do that. But at least you guys will be able to receive full credit for this class. And so you'll have something to take with you. And I looked at it from a bunch of different angles in that I won't be able to run the same class right away. And there's probably going to be a big backlog of classes trying to get in the shop anyways. So I felt like this was kind of our best option to give you credit. John's writing, hey, what about AT327? I'm reworking on the schedule right now. My thought is that we will still try to run AT327. Oh gosh, this is why I should use the typing tool. But yeah, we're still going to try to run 327 in the fall. But there's a lot of questions. We're not quite sure. So we're working on fall schedules right now. For summer,
I've already taken AT140, so how would that work?
you can take AT140 4 times.
Oh, okay.
Or you could do that 295 special projects class. Okay, so so that's why we have a couple different options. And I'm trying to work on those and get it figured out as to what the best option will be. So I wanted you guys to know that we're working on the fall schedule right now. For summer schedule, this is what we're going to run. I'll put it in this text box right here. We're going to run online only. And it's not just us, it's every college in the state basically is running online only. And
sucks because I was going to take archery in the summer.
Yeah, so I don't know what they'll be doing for PE classes. I know for us, what we decided to do is run a selection of classes. We're going to try to do an AT100 with Mr. Cohn. A lot of you guys know Mr. Cohn. He's going to try to do that at home where people are using their home garages. I'm going to do AT301. Oops, not 310, but 301, which is small engines. This summer, where people can utilize their, well, the nice thing about small engines is you can utilize your kitchen table in your apartment if you had to, right? Like, so it'll be utilizing what you have at home. We'll also run a 180 and then a math class. So I'll put those on there as well. We'll do AT105, which is math. That'll be online. And we're going to do an AT180, which is the data acquisition. So that'll be this summer. In the fall, we should have lab classes going again, barring no other, assuming everything kind of continues to level off and doesn't get tremendously worse. So, so with that, let's jump into, oh, Charlie writes, if I have a small engine at home, will that help with small engine class? Yeah. What we're going to do with small engines is allow people to work on their own stuff, and we're trying to figure out how to get people like engines if they need an engine. The neat thing about small engine class is it's something that you could find a busted up lawnmower or something around the house or in your neighborhood and take that and fix that up. So it's a class that I feel like if we were going to do any type of hands-on class at home, it's something that a lot of people could do at their home, because you could do it in your apartment. And I know that from firsthand experience, because early on I did some small engine work in my apartment. So it's something that you can do, and you don't need a lot of space for that. So
Ben,
if you have some broken down small engines in the backyard, That's perfect. I'm going to share with you all the tips and tricks and stuff, and we're going to get some resources available, and then I'll show you great places to get tools and stuff on the cheap. So that's what we're working on for this summer. All right, let's
I have one question.
Yeah, go ahead.
So I am taking AT105 and AT180 and they never told me if we were canceled or not.
Those classes should not be canceled. So all the 105s and all the 180s for this semester should continue and should finish up, because those classes are classes that can go online and that they don't require like a hands-on lab. So the 180 class, they should have given you passwords so that you can access all data and ShopKey online. And with the math class, Chris Moore's class has a lot of online stuff, and then Dan North has been trying to post videos and stuff. So if you're having problems with that, send me an email and we'll get you taken care of. Yeah, and Bliss does a good job for parts. Citrus Heights Mower is also very good. All right, let's get into some information. All right, actually, before we get into this, I need to back up because I want to go into porting and gasket matching and relate the carburetors to flow bench, right? So I'm going to actually switch this over to the document camera here.
Mr. French?
Yes.
Since my bike is in the garage,
we will get it back to you, or we'll figure something out.
Yeah, with a full tank of gas, could you at least go in there and treat the gas tank?
Put some fuel stabilizer in it? Yes.
Yeah.
As soon as I get into the college, I have not been able to get back into the college as of yet.
Okay.
But I'm working on it. All right. We're going to open up the document camera here. Perfect. We'll move him over right there. All right. So we got our workbook up here, and the first thing I wanted to do actually is a few weeks ago we had talked about flow benches and porting, and I think I had shown you some engine parts. And I was talking about how the majority of your performance enhancement would be right around the valve seat area, okay? But then we also talked about gasket matching, and I didn't have some gaskets set up ready to go. And so today I do have some stuff here. So here's the same cylinder head, and this is the intake port. And so if I were to start putting pieces on this thermal plate right here, if I look at it, on this side you can see how it's more of that D shape, and on this side it's round for the carburetor. So I'm going to put him on place there. And then there would be a gasket for this guy, so I guess I should lay that down there. And so when we think about gasket matching, well, one thing you'll notice is that, hey, this gasket, it's smaller than that port, right? So what I would want to do if I wanted the most amount of flow here is I would want to trim this gasket to make it match at least the port. Oftentimes you'll put a gasket on a port and the port will be smaller than the gasket material. So then you enlarge the port to the size of the gasket. Okay, in this case, I have the opposite situation where I have a gasket that's a little small. Then I have this plastic spacer here that would go on before we put on our carburetor. Now I wanted to ask you guys, why do you think they would put on that plastic spacer like you see right there? What's the purpose of having that plastic spacer on there? Well, one of your challenges.
They give it more time to atomize.
Yeah, actually, you have the spacer does help with the intake track length, but specifically making it plastic helps prevent the heat transfer from the cylinder head that's going to be pretty hot to the carburetor, which is fuel in the float bowl. So if we don't want the fuel to boil out of the float bowl, this plate acts as a thermal barrier there to try to keep the fuel from cooking in the float bowl. All right. So with that, of course, I'm sliding the carburetor on backwards because this carburetor doesn't have a throttle in it. So here I have all my parts. I'm stacking them all.
So,
together
Professor,
here
I've
with my
seen
various
like,
parts. Yeah.
Professor, so I've seen like
Yeah.
on Hollies where they got like the plastic ones or some type of composite material, but I've also seen aluminum blocks. So would the plastic be better to use?
So the downside with the plastic is it tends to warp and sometimes can crack, but the advantage of it is it is a much better thermal barrier.
Okay.
So
Thank you.
there's different sides to each thing, right? Some guys will like one versus the other, but if you can keep the fuel cooler, it does lead to more power. In fact, this carburetor right here, this Eldebrock, this is basically a copy of the old Carter carburetor. And Carter used to make these things out of plastic. So see this body part down here that's all aluminum? Back in the day, Carter made it out of a phenolic, and they called it the thermal quad. And the whole idea was to try to keep the fuel in the carburetor as cold as possible. The downside, again, though, is that that plastic body would warp or it would crack, right? So it's like you're compromising between durability and thermal protection. So that's why most carburetors will be made out of aluminum, but they'll have some type of plastic spacer plate there to try to give you some thermal barrier. So
I always thought those plates were acting like, you know how the tonal rams, they give it a lot more space in between the engine. The bigger spacer you have, it would just help with the air. Is that an old technique?
Well, they do that as well. They do that as well. And actually, by adding spacers to the intake length, it does give you that ram effect, and it can move the power band up in RPM. So you are correct in that will affect the airflow into the engine, but also the material of the spacer can act as a thermal barrier. Where you think hot soaks enough, the temperature of all the parts will be the same at some point, right? But on like a hot re-soak type deal, like you drove your car, you shut it off, it's sitting in the parking lot, then you hop back into it. The fuel is much more likely to boil out of the float bowl with that carb application, so I'll have some type of thermal barrier there. All right.
Thank you.
So what I wanted to get to was if you were gasket matching here, and I'm looking for a couple other gaskets that I had. If you were gasket matching, you would be trying to enlarge your ports to match the gaskets, or like I have on this engine here, I would want to enlarge my gaskets to at least match the ports, because again, for my exhaust gasket, it is smaller than my port. So I brought one more curveball to the equation here, and I want to say somebody had asked me about this last week, but that is restrictor plates. Like in NASCAR, for instance, they
That was
use
me.
restrictor plates to limit the engine's power. And so here's a restrictor plate that we used in karting to reduce the power of these clone engines for junior drivers. And so this would be something that they would tack. It's a specific size. This one is a 1/2 inch. If I zoom in on that, and then that sets up a whole different dilemma on there, but it really restricts the airflow through the engine to restrict its power. It's also going to change the whole torque curve and everything of the engine. So anyways, if you were porting an engine, when we talk about gasket matching, you know, we're either making the gaskets match the ports, or quite often the gaskets are larger than the ports, so we're enlarging the port to the size of the gasket. All right. That intake track together. I'm going to get this little head out of here. Now, to relate your carburetors to your flow bench, if you had read through in the flow bench materials, they actually did talk about it here a little bit. If I can get my tab working. And in the manual, we'll zoom in on this thing and we'll try to focus it there. Let's try to figure out what to focus on, I think. But they talk about how early on for carburetors, they ran them at 3 inches of mercury. Remember on those flow benches, especially the older ones, it had those big, like, manometer gauges. It had those big, like, vacuum gauges. Well, they initially tested carburetors at 3 inches of mercury. When they came up with 4-barrel carburetors, they realized, oh, well, that's too much of a pressure drop. So for those guys, they went down to 1.5 inches of mercury. So carburetor testing is a little weird because they've chosen this nominal value of 1.5 inches of mercury, okay? Well, that's quite a bit of a pressure drop that they're testing at. If you switched it with water, because mercury is heavier than water, right? It would be 20 inches of water. So this is the standard that the industry chose a bunch of years ago. However, so when they say I have a 600 CFM carburetor, what they're saying is we have a 600 CFM carburetor with 1.5 inches of pressure drop through it. Well, that 1.5 inches of mercury drop through there, that probably would be restrictive if let's say your engine really could only flow 600 CFM. This would cause you some power loss here. So the formulas we looked at last week are not assuming this 1.5 inch pressure drop. That was just a standard that the industry chose for flow testing carburetors, and so that's why the formulas I gave you kind of take that into effect. All right, so what we do on the flow bench does relate to carburation and everything else. Last week, Frank, you had mentioned carburetors with flat slides, and I said, "Oh, where's my shifter carburetor?" Well, I grabbed a couple other carburetors here to show you this week. This is a carburetor off of my CR125 shifter cart, and this carburetor has been specially modified, but it's a Mikuni, and it is a flat slide style carburetor. So on this style of carburetor, the slide acts as the throttle valve by opening and closing. That's what your throttle cable is connected to. So that acts as your throttle valve, but it also is changing the size of the venturi inside the carburetor. So it makes the carburetor very adjustable to the engine's demands. So the vast majority of your motorcycles and high performance small engines, even some of your like British and Japanese sports cars that were carbureted would use a carburetor like this. They would be a side draft carburetor because the air flows sideways through the carburetor versus a conventional automotive carburetor. This is a downdraft design, right? So they're a side draft design carburetor, and they really do give you a lot of tuning capabilities. Now, for whatever reason, because this guy essentially is variable Venturi, Ford tried variable Venturi carburetors, so did Toyota and a few other manufacturers. For automotive engines, variable Venturi carburetors never quite worked out. It seems like when you had a bigger engine that needed more airflow, if you started making this variable Venturi too big, it would lead to warping, and they just had all kinds of problems with their variable Venturi designs. So that never quite worked out in the automotive application. Super popular in your small engines, and like I said, some of your small sports cars would use single barrel carburetors like that right there. Now,
couldn't they use stronger materials that wouldn't warp?
Yeah, it just never really caught on. You would think that they would have been able to make it work, and it never really did. Ford is the one manufacturer that really tried to mass produce a variable Venturi 4-barrel carburetor, and it just never worked right. It got out, and they just had all kinds of problems with it, problems when people serviced it and everything else. So
Subaru is pretty good at sideways stuff. They could probably do something.
Yeah, maybe they could. Of course, now we're on the fuel injection anyways, so we're kind of past it. But it just never really panned out. So if you get a chance, if you look up Ford variable Venturi carburetor, you'll see all types of stuff about it, and several horror stories there. So not only is this a Mikuni motorcycle style carburetor that is variable Venturi, it gives you some unique tuning characteristics. For instance, we talked about how it would have a main jet here in the bottom and you could change your jetting. But going in and out of that main jet attached to the throttle valve is this metering rod. And so if I put the metering rod in the slide, you can see how it would go in and out of the carburetor. And so as you're opening up the throttle, what you're doing is you're taking the metering rod out of the jet, right? So not only could you change your air-fuel mixture at wide open throttle by changing jets, but you can also change your part throttle performance. Yes, you do have some adjustments that you can do to the pilot system, right? The idle mixture, if you will. But you can also change what position that needle's in. And you can change needle shapes and stuff as well. But what is very commonly done is you can change the position of the needle. So if I zoom in on the top of this needle, you can see that there's a little E-clip on that needle, right? And there's 5 different slots, and right now it's in the middle position. So if I move the clip down, it would then move the needle up out of the jet, right? It would enrichen things. If I moved the clip up to the top groove, that in turn would move the needle down into the jet and lean things out. So it would affect kind of your part throttle applications of what your air fuel mixture doing at part throttle, because you're controlling how quickly the needle moves up out of the jet as you're working that throttle. So that would be an example of what we would call in an automotive carburetor like your power enrichment system. But it gives you some adjustability here because you can control where the needle's at in the jet. So hopefully that makes sense to you. It's one more thing to tune, right? So if you feel like it stumbles a little bit as you start to rack open the throttle, one adjustment you could make would be to lower the clip. That would pull the needle out and give you a little bit more fuel for that part throttle operation. In addition to adjusting your idle speed mixture. All right, and on this carburetor, I was looking for that. Here it is. So if I look at the carburetor body, let me zoom out. the big screw on the side, that's your idle speed. What that does is it screws in and it actually comes in to the side of this guy and affects the position of the slide inside there. So that's your main idle speed. This screw right here is your pilot air screw, or think of it as your idle mixture. If I flip the carburetor over, what I'll notice is that there is a hole right here that air can go through, and we're affecting the air that goes through the idle system or the pilot system on a motorcycle carburetor. So that's how we affect our idle mixture. And if we turn this screw in on this guy, it will richen the mixture. And if we unscrew it, it will lean it out, because it will let more air from here into the idle circuits or pilot air circuits. You'll also notice, hey, there's another hole over here. What's going on for that? If I follow that around, you can see that that goes to my choke system, which allows additional air in and additional fuel to enrich in the mixture for a cold start operation.
And down and to the right is also the drainage screw.
So to drain the float bowl for this guy, if I put the float bowl on here, you could just take the bottom out of the float bowl there. It doesn't have a screw for this one, but that's like if you tip over your motorcycle and you see fuel spill out, it's going to spill out this guy right here. And it's also likely to spill out the side vents of the carburetor there and there. So these are my bowl vents. And what we've done on this carburetor,
the screw is on the top of the carburetor, though. If you look on the other side,
screw on top of the carburetor.
Not like top, but I mean like the top piece, but in the bottom area, right where you're down and to the right. Isn't that it right there?
No, this is your pilot air screw. This is your idle. This is like your idle mixture. So there's your idle speed. There's your idle mixture.
All right, because that's usually
this is a bowl overflow drain, and then these guys, these vents, this hole here, you can see that passage goes down, and if I flip this over, you can see that this passage goes down. These are my bowl vents. Now, normally these would have hoses going down the side of your carburetor, and it would drop down to your swing arm. Because we had this on a goat cart, what we did with these bowl vents is we would attach them together, cut the hose in the middle, and that would go up like that to give us a nice venting of the float bowl. Again, if you were to fall over with your motorcycle, then the fuel from the float bowl would drip out of these bowl vents on the sides. All right, so there's one other
that's why I always put my
this carburetor.
That's why I always put my overflow hose to the intake. So if it started leaking out of that, it'd just go right into the engine area.
You'd be careful though, because you wouldn't want to just
yeah, you'd flood
your motor full of fuel. So this carburetor has this weird tube coming out right here. And what that is you notice that there's no float bowl in this carburetor. In fact, the float would normally hinge right there, and all that's been replaced. So I do not have a needle and seat anymore. That's where the fuel comes in from the fuel tank. It comes in there. It just dumps down into the bottom of this bowl area. And then it's got this pickup tube, if I can get it up on the screen right here. It's got this pickup tube right here. And this carburetor was set up for what they call a pump around system. In the application we were running this carburetor, it was on a shifter cart where you would be pulling a tremendous amount of G-forces through corners. And because you were pulling all these G-forces through the corners, what wants to happen is the fuel wants to all slosh to one side of the float bowl. And that would prevent, proper carburation from occurring. So we would fill this bowl area full of foam, and you can see some of the foam residue in here because I had to clean this carburetor out. But we fill it with foam for fuel cells, fuel resistant foam, and then we would run one fuel pump that would be pumping fuel into the carburetor, and it would be discharging out right here, which replaced the needle and seat. And then we would run another fuel pump evacuating or pulling fuel out of the float bowl right there. So this pickup basically is what set my float level or the fuel level inside my carburetor.
Wouldn't
So
you need a needle and seat to stop the fuel?
No, the needle and seat is there to, yes, stop fuel flow, but it regulates how much fuel is entering the float bowl. So as long as you're sucking out the excess fuel out of the float bowl and returning it to the tank, you're fine. You just don't want to fill this thing all the way up and the fuel's just pouring into your engine. So normally we do that by pinching off fuel flow and only letting in what the engine needs, right? Here, we're pumping in way more than the engine needs, but we're also sucking out the excess. So it's called a pump around system. It would require you to have two fuel pumps on your engine, one delivering the fuel and the one sucking out the excess. And it worked really good in karting, especially if you were racing on circuits that had like high G corners where you were loaded in the corners for a long time, because otherwise you're likely to run lean because all the fuel would go to the side of the float bowl and you would run out of fuel. You wouldn't have fuel then covering your jet and your engine would go lean and burn up your engine. So anyways, so motorcycle carburetors give you more tuning opportunities there. And then you can see this is one that's been modified for a different application. Two last carburetors to show you real quick. Some of you guys are probably familiar with little carburetors that look like this one that have one of these little primer bulbs on them. This is one off of a little string trimmer, or it could be a chainsaw. This is what I call a diaphragm style carburetor.
I wish you had my carburetor because I modified it to go on the smaller intake port. So
when I get to be able to be in my office again, I'll have to grab it.
Yeah, so I have it where it's like hose clamped onto it to the intake area, when normally the carburetors for those kind of engines, they bolt on.
Cool.
Because it's a special type of intake boot that I have.
So these diaphragm carburetors, why you commonly see them on string trimmers and weed whackers, is because you got to be able to operate that engine at all kinds of crazy angles. And having a float bowl doesn't work. So these carburetors are basically, this carburetor is two things in one. It's a fuel pump. So this side is the fuel pump, where it uses crankcase pulsations to draw fuel up to the fuel pump. And then it has a diaphragm inside there like this. That's the fuel pump diaphragm. Those are the check valves. On the other side of the carburetor, it has another diaphragm here that regulates a needle and seat and basically acts as your float bowl. So this guy right here would operate that little fulcrum, and it would then move a needle off a seat. So these little carburetors that you see on string trimmers and weed eaters and maybe some go-kart engines, like this is off a KT100, it doesn't have a traditional float bowl, but we know it still has to do all the same jobs as a regular carburetor. It does that with some extra diaphragms, so I call it a diaphragm style carburetor. One other tip on those little types of carburetors is hidden on the fuel pump side. There is usually a little tiny fuel filter in here that's a little tiny wire screen. So if you bypass the fuel filter in the engine, or you're not running a fuel filter, it has an extra little fuel filter in the carburetor. And a lot of times people won't clean this one, and this is the one that's clogged inside the carburetor there.
Wouldn't it be easier just to replace it instead of having to take apart that tiny little thing?
Yeah, most small engine shops are not going to rebuild one of these little carburetors. They're going to put a new one on your engine, and a small one like this might cost anywhere from $30 to maybe $60.
That's pretty expensive.
Bigger ones will cost more money. Well, if the shop charges $100 an hour labor, though, it's just cheaper for the consumer or the customer to replace the whole carburetor, right? So most small engine shops, if you went to Bliss or any number of them, they're going to just replace the carburetor. However,
Yeah, because I
let's say
know
you're doing a racing deal where you have this diaphragm style carburetor, well, that's going to be all set up very specialized to give you the right performance, and they can actually blueprint this carburetor to make sure you're getting maximum airflow. This one, you can see it's got the mixture screws for the high and low. So these carburetors, one of the things I do like about them is there's no jets on here. There's mixture screws, and I have a mixture screw for the low speed, and I have a mixture screw for the high speed. So I can adjust this carburetor on the fly, and that's one of the neat features about it.
I was
And you
saying,
can see that even in small engine stuff, it's the same setup with the mixture screws. These usually, though, they try to put some caps or something on there to keep the consumer from messing with their fuel mixture. All right.
I was saying it was expensive because normally you can get like dirt bike carburetors for like $20 on Amazon.
Well, I don't know what. I mean, you're not going to get something like this Mikuni for $20, or if you do, if you're finding this,
You can
style
find a
of carburetor,
Mikuni for like 30 though.
really?
Yeah.
You'll have to share where you're finding these carburetors for that cheap, because I would like to know. This one I got from Sudco, and I want to say it was $230. So, all right, moving along. We got to keep going here, and we're going to talk about engine RPM and Redline. I guess one last thing to review. If you have a carburetor with metering rods, remember that's one more adjustment. And if you move the clip down the jet, what's that going to do to the air fuel mixture? If I move this clip from the middle, I move it to the bottom. What do you guys think? Would that make it run richer or leaner at part throttle?
Richer.
Yeah, it'd be richer because it's pulling the metering rod out of the jet, right? If I move the clip down, that's going to lean it out because it's pushing the metering rod into the jet. Good job, guys. Yeah, so it gives you one more thing to tune. And I'll tell you, it's pretty rewarding when you're able to do like a jetting change, or you mess with a mixture, a metering rod, and affect the air fuel mixture. And then that allows you to pick up time on the racetrack or make your bike run better. Or, so there's all kinds of stuff that you can do. You know what? We should do one more thing though. We should go. All right. Let's say here's our carburetor, and Frank and I, we're going up dirt bike riding, and we're going up to I don't know, way up in the mountains, not quite to Nevada yet, but we're going way up in elevation, right? Here's all of our jets and metering rods and stuff. If I go up in elevation, what do I want to do with the air fuel mixture? Do I want it to be richer or leaner?
Leaner.
Yeah, I want it to be leaner. So I'm going to choose jets that are smaller, okay? And let's say I was ill prepared. I didn't have my big thing of jets. One thing I could do is I could lean it out by unscrewing that screw a little bit, and I can move the metering rod down into the jet a little bit more, and that might make my bike run pretty decently for my trip, right? So now that you guys know this stuff, you can make some of those carburation changes. What you will typically find is the vast majority of stuff is probably jetted a little bit on the lean side for emissions.
The lowest I'm seeing a Mikuni on here right now for is 75.
Really? Okay, so you have to You have to share those web addresses.
It's one of the 30 millimeter ones.
All right. So we are going to switch gears and we're going to talk about engine, RPM, and Redline, and determining your safe engine, maximum engine RPM. That's what we want to do here. So let's take a couple steps back as we talk about engine RPMs and Redlines. We're talking about RPMs, or revolutions per minute, on the crankshaft, right? RPM of the crankshaft, how fast is this guy spinning, right? Now remember, if we were turning 8,500 RPM, remember that we only have half as many, or 4,250 four-stroke cycles happening, because it takes 2 revolutions of the crankshaft for 1 4-stroke cycle, right? But still, every revolution of the crankshaft, I have pistons moving up and down, and so there's a lot of parts and pieces spinning around in there with each revolution of the crankshaft. So RPM is speed of the crankshaft. All right, well, what limits our RPM? Well, there's several things. Usually in a stock configuration, what limits my RPM is breathing or airflow in the engine. The engine can't flow enough air due to restrictions in the heads or maybe the camshaft profile, and it's essentially like the engine is trying to suck air through a straw. And so at some point, I just can't get enough air into the engine, so that limits the speed of the engine. It limits the RPM because I can't support any higher RPM. I just can't get enough airflow in the engine to support higher RPM. So in a stock,
I put the link in the discussion.
Awesome. Awesome, really good. Okay. So oftentimes what limits RPM in a stock engine is going to be airflow. And it's like it's literally sucking air through a straw. All right. Well, then the second thing that happens is maybe you run into valve train issues. It could be valve train in that the cam profile doesn't allow the valves to be open long enough to get the airflow in the engine, or it could be a valve flow issue, and we'll get to that more in a minute. And then ultimately, if I fix this issue, if I have an engine that can breathe well, and I put some good valve springs in there so valve float's not a problem, I fix that issue, then our issue becomes mechanical. Crankshaft, connecting rods, main bearing caps, rod caps. How can I keep this engine together and keep it from blowing up? Okay, so we'll clear those drawings and we will move to the next slide. So what is valve float? Valve float is the valves not closing at high RPM. So what happens is, even though the camshaft, either directly or through a rocker arm, the camshaft pushes the valve open, right? But it's the spring that ultimately is making the valve close. And at high RPM, there's only so much time for the spring to close the valve. If my valve springs are not strong enough, then it's not going to get the valve closed in time for the next 4-stroke cycle. So what happens is I have a loss of compression because I'm not completely closing the valves. And that's going to cause the power to drop off. So I'll give you a good example of this with the little engines that I have right here. These little clone engines were classic for this. When we first took these engines, and you bought them from Harbor Freight Tools for $130, you would adapt it, put it on your goat cart. Basically, this engine, it would float the valves pretty much right at 5,600 RPM. It would float the valves. It would act like a built-in rev limiter, because before the connecting rod blew apart, the valves would float at 5,600 RPM, and that the valve spring was just not strong enough to close that valve, and it limited the power. Well, then racers being racers, what did companies do? Companies came up with their own really high-end valve springs. So they made valve springs that were higher performance, that were stronger, and now the valve spring was so much stronger, now I could rev this engine up to almost 7,000 RPM. And then we started having other issues. So we
one thing about Mikuni carburetors, they will sell them without the Mikuni name on them, but just have the parts number, and they're extremely cheap in that way.
Oh, okay. That's good
Like if
to
you
know.
just find like, say, like a VM30, it's just a 30 millimeter Mikuni carburetor, just without the name, and it's like $30.
Really? I'll have to check that out. Thank you for sharing that, Nathan. So put in stiffer valve springs, and now we had all kinds of problems where we had like the flywheels were blowing apart. So then they started selling these billet aluminum flywheels, and the whole thing went on and on and on, right? So by the one thing of changing the valve springs where we could go to 6,000 or 7,000 RPM because the valves would not float, now the engine would start revving up more, and that caused a bunch of other failures. And then the weak point became the connecting rod. It would start failing. And then, of course, there would be billet replacements for that as well. So if I switch this back to my computer, once you get the engine to breathe properly, your next problem becomes getting the valves closed in time. And so if you want an engine that's going to rev up to higher RPM, one of the things you're going to have to do is put in stiffer valve springs in here, okay? Because if the valve springs aren't stiff enough, they're going to float, which means that you're going to lose compression because the valves are not going to close at high RPM.
You're also going to want to change the valve springs if you turbocharge it or supercharge it as well.
Well, if you're not revving it up to higher speeds, you don't necessarily have to change the valve springs. There is some pressure differences there, but the RPM is a bigger factor than anything else. So keep in mind, if you have valves floating, you can have piston to valve interference, or basically valves can hit the pistons and cause all kinds of damage there, right? So that's something to look at. If I'm trying to do higher RPM, do I have valve springs that can support that? Now, the other thing you'll see is that people will put on like roller rockers. Well, now the rocker has weight and mass to it, maybe more so than it had before. And now I need stiffer valve springs to keep the valves from floating, because now I have the weight of this rocker that I also have to move back and forth, right? So anyways, valve spring tension's a big deal. And if I'm trying to do more high RPM stuff, I need stronger valve springs. Of course, if I get stronger valve springs, like I showed you with the clone engines, that's going to necessitate other changes down the road. So let's say I have an engine that breathes well, and I have an engine that has stiff enough valve springs. Well, now I'm going to have possibly some bottom end failures, where I could have connecting rods blowing right out of the side or right out of the bottom of the engine block. And once that happens, that whole engine's done. There's not anything you're going to be able to really salvage out of this engine. It's going to create a ton of damage. So what do we do about that? We're going to try to make sure that we have good parts in our engine. Here's one that's totally toasted. You can see the crankshaft's broken in multiple spots. I mean, this thing is just junk. It's garbage. So this is not where you want to be, right? You don't want to end up in this situation.
I wonder if some of the engines from the engine repair class ended up looking like that.
I did have one engine actually blow up like this. And what happened is I had students that didn't properly torque down the rod caps. And like Mr. Tuso, I used to really try to push everybody, get their engine done and get it started. Well, I had a situation where I had a group member where his members dropped out of his group, so he's working by himself. I had other people come help him. In the mix of all this stuff, not all the connecting rod caps got tightened. And so when we went to fire up the engine, it ran for a few seconds and it threw a rod. It didn't do this much damage, but it did a considerable amount of damage. It did crack the cylinder. It did ruin the crankshaft. It actually broke the camshaft, poked a hole in the oil pan. It wasn't this bad, but it was bad enough that I realized that when stuff goes wrong and a group gets way behind, if I could just have them assemble the engine, I would give them partial credit for that, because when I pushed people too hard, this is what I ended up with. So it's trying to find that balance point.
Yeah, right. I sometimes think the if it doesn't run, you fail kind of thing is kind of strict.
Yeah, so I got away from that, and I did it on a point scale. So to get full points in the lab part of your grade, you had to make your engine run, right? But then it was a sliding scale down from there. Because honestly, as you saw in your class, you know, just things would happen that would prevent the students from getting their engine completed in the time you had available.
Hopefully, Tuso can get in there and get our engine to run, because that's all we really need to finish our lab requirement, and we can do the rest of our online work.
Yeah, Nathan, he should have sent you an email too that I wrote up for him for your group in particular. But we can talk about that
Okay.
Outside of class time here. So, so let's just going back a bit. If we have the engine breathing issue fixed and we have stiff enough valve springs where we no longer have valve float issues, and now we're just worried about the low end, the mechanical stuff, right? Well, if we're concerned about the mechanical stuff, we can figure out our safe RPM based on what parts do we have in the engine. And so this is the formula. You take the RPM of the engine.
That says FPM.
FPM.
Oh, wait.
What do you mean?
It says...
Oh, that the cut. Yes, because the FPM stands for feet per minute. So feet per minute, FPM. So this formula, what we're going to do is we're going to take the RPM, we're going to multiply that by the stroke, and we're going to divide it by 6. And that's going to give us a number in feet per minute. And so once you have that number in feet per minute, the basic rule is this. If you have a stock engine, right? Let's say you have that very stock small block Chevrolet, 3,500 RPM, or I'm sorry, 3,500 feet per minute is what I would want to determine my red line. If I had built it up pretty good, maybe I have some ARP rod bolts in there, maybe I'm going to go to 4,000. If I have some really nice low-end components and it's really built up, maybe I could go to 4,500. If I have an all-out race motor, 5,000. What you will see on this is it's not only about the parts, but it's about the stroke of the engine. So,
what allows formula engines to rev to like 20,000 RPM?
Well, really good parts, right? Really good parts, but also those Formula One car engines, they have a big bore and a very short stroke. Because as I have here, hey, it's all about the stroke. Because what are we doing? We're taking the speed of the engine and we're multiplying that by the stroke. So if I want my engine to withstand real high RPM, one way to get around that is to go to a short stroke. So for instance here, we have two engines. One has a 3-inch stroke, the other one has a 3.5-inch stroke. We're revving them both up to 7,000 RPM, right? Well, one will come out with 3,500 feet per minute, shorter stroke, or over 4,000 feet per minute. So if I go back to my previous slide here, you can see that, well, on a stock motor, that I could go to 7,000 RPM on the stock motor if I had that short stroke, but I'd be pushing it on my stock motor with a 3.5-inch stroke. So what has the big influence on how many feet per minute your engine's going through? The stroke does. And why is that the case? Well, if you think about it, this connecting rod, he's going to go to one end, and then when the crankshaft rotates over, he goes to the other end. And at each end, he comes to a complete stop, doesn't he? So he has to stop, accelerate to maximum velocity, and stop again. And then accelerate to maximum velocity and go the other direction, right? If I have a longer stroke, that means I'm increasing my piston speed because now I'm moving it physically a longer distance. So the stroke is a big deal. So Formula One car engines, right? Engines that are going to rev up to a lot of RPM typically have a short stroke. And you'll hear a lot of engine builders talk about big bore and a short stroke as a way to still have displacement in their engine because of the bore size, but to handle high RPM, right? So if I still want my displacement, my bore's got to be big, but if I have short stroke, then I could rev it up, right? If I have a real long stroke, then it's going to naturally going to be more of a lower RPM engine because it can't handle that high RPM. If I want to build up my engine, how am I going to do that? As this slide explains, is I might start with some better rod bolts here, right? If I want to go to more RPM, maybe I'm going to go to better rods themselves. Also, if I change the length of the rod, it will change the speed, which that'll necessitate a piston change oftentimes. Better main bearings, right? My 4-bolt main versus 2-bolt mains. Really good bearings in my engine. Of course, oil pressure, clearances, and lightened components. All these things are going to help you withstand more engine RPM. So if, let's say you're not the engine builder, let's say you're the EFI tuner, and you're going to program in what the Redline's going to be for the engine, well, you need to know about what components are in the engine, because if it has a bunch of these parts, that means that you could then in turn have a higher Redline because you have a better built engine here, right? So
don't some engines like the LSX have like 6 bolts for their main bearing cap?
They do. And so right off the bat, that engine could handle more performance. So like a regular 2-bolt main small block Chevy, here he is right here, right? You take one of these LS series motors and you're starting off kind of right in this range here. So right off the bat, it can handle more RPM because it's built better. Even if you took like a stock Honda, you know, Civic Si, like those things rev up, well, they don't, their components aren't all real heavy, but they're also really well built stock engines so they can handle more piston speed.
Yeah, knowing
Okay.
Honda, they love the rev limiter.
Right. So
They truly
again,
do.
it's all about a factor of the stroke. So you need to know, if you're the tuner, you need to know what parts are in that motor so you can determine what is a safe red line for the engine. Where do you want that fuel cut to come into place? And that's based on what's the bore of the engine, what's the stroke, specifically what's the stroke of the engine, and then what components do they have in that engine, right? If they have a shorter stroke or they have better components, then you can handle more RPM. All right. So that's why I have here, you have to do your homework before you start revving up that engine, right? Do your homework before you rev. And keep in mind that you have multiple problems to confront, right? Your first problem is airflow. Are you drinking through a straw? Because if you are drinking through a straw, you're not going to get the airflow to withstand high RPM. Once you get the airflow dialed in, then the next thing is going to be working on the valve train, right? And just like the clone motors that I was showing you, once we put in stiffer valve springs, then that was an issue. Then we had to work on the low end and everything else. So you really have three issues here that you have to work on and worry about. Now, I got one other little tech tip for you today, and that is related to airflow. We were doing carburation, airflow, and we know that is directly related to the engine's power, right? But it's also related to volumetric efficiency. So let me clear my drawings there, and let's see how this guy plays.
Volumetric efficiency compares the volume of air entering a cylinder during intake to the internal volume of the cylinder when the piston is at bottom dead center. It is usually expressed as a percentage. In a naturally aspirated engine, one without forced induction, volumetric efficiency can never be 100%. This is because of the resistance to the airflow that occurs at the carburetor, manifold, and the intake valve. With forced induction, the incoming air is compressed, so that a greater volume and mass of air is forced into the cylinder during the intake stroke. That takes the volumetric efficiency to above 100%.
So what I liked about this video is they even showed us the carburetor with the Venturi area on it, and they talked about volumetric efficiency, and we know that the higher our volumetric efficiency, the more power we can make in the engine, right? And of course, with that, if I have a freer flowing intake system, that will help us improve volumetric efficiency, which will help us improve power. So that brings me to air filters. And for that, we're going to throw on our document camera. And I have an air filter right there, right? How many of you guys have used, some type of aftermarket washable air filter? You guys tell me. How many of you guys have used this style of air filter, whether it's a K&N filter in your car or something like this? So it would be on your motorcycle. This actually went on this clone engine right here. And so you could see when we modify the intake and we put a better intake and exhaust on, all of a sudden that could support the airflow. So what I wanted to get to today was the servicing of this style of air filter. And you can see that this guy's pretty dirty, right? He's got bits of dirt and grass and stuff in there. And of course, when they come new, here's a brand new one. This is off of a Briggs 206 engine. There's that brand new filter element. Before we use this filter, what should we do with it? What should we do with that, that filter before we use it? Anybody?
Low bench it.
We should oil it, right? Whether we use, this is Canon air filter oil. This is technically a green filter. I guess I could use the green air filter oil, but we should oil it. I'm sure a lot of you guys have heard how these filters flow more airflow, right? Well, if this style of air filter is going to flow more airflow than your stock air filter would, how's it going to do that? Well, it's going to have bigger holes in it. So this is the stock paper pleats of my air filter, right? This high flow filter, if it's going to flow more air, that means it's going to have bigger holes or spaces between the pleats. It's going to have bigger spots for air to get in the engine, right? And that's how it can physically flow more air than the stock filter could. Well, then it comes down to, well, how's that filter going to filter out the same amount of dirt? It actually relies on the oil. It relies on the oil, because what the oil is going to do, if I coat these with my air filter oil, what the oil is going to do as the dirt goes to go inside the motor is the oil is going to attract the dirt. So the dirt hopefully will come in here and he'll get stuck in suspension with the oil, and then it won't go into the engine. So I guess what I want you to know is when you buy a K&N or some type of similar air filter like this, it's relying on that you oil it. It's not going to filter out the same amount of dirt particles as the stock one would, because it physically has a bigger micron, bigger holes in the filter material that allow in bigger chunks, a higher micron level of particulate in the engine. And the only way it would give you the same level of filtration is if it's properly oiled. Okay, so you wouldn't want to use this air filter dry. In fact, if you used it dry, what would happen is that dirt would get stuck inside the filter, and it would basically get embedded in the filtering material, and you wouldn't be able to wash it out. The only reason you can get the dirt out of the filter is because the dirt's held in suspension with the oil. So when you clean the filter with your filter cleaning kit, right, it comes with the bottle of cleaner stuff. When you clean the filter, you wash the oil away and it takes the dirt with it. So if you're using your filter cleaner and you haven't oiled the filter, you're likely not to get all the dirt out of that filter. So don't use these filters unoiled. But there is a downside to the oil in the filter. And that is, if I can find where I put it, here it is. That's this guy right here. What is this thing? And thank you, Luke, for sharing this with me. This is a mass airflow sensor, mass airflow sensor. So what he does is, you can see that this is my air filter box. Air goes right from the air filter. It goes through this hole inside the mass airflow sensor. And inside there, the air is going to flow through a little passageway. And on that passageway, the air is going to go over a piece of, let's see if we can get it where you can actually see that. the air is going to go over a piece of resistor wire. Now, a computer is going to send electricity through the wire. So I got a positive and a negative here, and he's sending some power through the wire to heat up the wires. So they call it a hot wire sensor sometimes. As air flows over the sensor, it cools the wire off. And so then the computer has to send more power through the wire to heat him back up. Okay, so that's how this type of sensor measures accurately not only how much air is going into the engine, but it also measures what's the density of that air. So if there is more moisture in the air, if the air is more dense, then that will cool this thing off as faster, and then it knows to then tell the computer that information, and the computer will give the engine more fuel. Okay, so how do I relate this hot wire mass air flow sensor to this air filter? Well, if I oil up this air filter a lot, oil can come off the air filter and it can get stuck on the hot wire. So that oil would then act like an insulating blanket, and it would contaminate the mass airflow sensor. So the downside of this style of air filter on your passenger car with a mass airflow sensor, which is exactly what we have here on Luke's Thunderbird here. It's got this mass airflow sensor, but he also had a Canon air filter in there. The air filter needs to be oiled, but you need to be really careful to not over oil the air filter. Otherwise, you're likely to wipe out the mass airflow sensor. Okay, guys? So don't run your air filters dry like this, but also don't go so crazy with the oil, especially if you have a fuel-injected car that has a mass airflow sensor like this one right here. Okay, and then next week we'll get into
couldn't you bypass the
servicing
sensor?
You could, like some aftermarket injection systems, like Motex and Haltex, will not use a mass airflow sensor. But what you really want to do is service the sensor and clean it with the right product on a regular basis, and we'll talk about that next week. So today, don't forget that this style of filter, yeah, it does flow more air than your typical pleated paper stock air filter, but that's because it's got bigger micron holes in it, right? And it's relying on the oil to aid in filtration. So don't run those filters dry, but also be careful if you have a car with a mass airflow sensor that you don't over oil the guy. Now, of course, if I was running this thing like on a small engine that's carbureted, well, it's not a big deal because I'm not going to wipe out a carburetor. So I just have to make sure I have enough oil in there so that it traps the dirt, but it doesn't impede the flow of air through the filter. And I have seen people actually dump so much oil on these filters that it actually restricts the power of the engine because the filter is so oiled up and dirty. But now, hopefully that makes sense of why they'll say, like Canon likes to say, hey, as the filter gets dirtier and dirtier, it filters better. The reason that thing would filter better is because now it's more clogged up and it's getting smaller micron holes in there. Anyways, all right. Well, guys, thank you so much for being with me today. As always, I will get this lesson loaded up on our Canvas site, and I'll copy it to YouTube, the recording. I would encourage you guys to go on the Canvas webpage. I did post a little thing about a couple of questions on carburetors that we did talk about today and last week. And I'm hoping that you guys can answer some of that stuff and follow along with what we're doing. Next week, we're going to get into fuel injection and fuel injection tuning. to give you some chance to talk about that. Also show you some software that you can download to play around with that stuff. And then we'll be good. After that, we'll be getting into intake and exhaust systems, and then forced induction, which would include supercharging, turbocharging, and nitrous. So
That's the fun part.
Yep. So until then, everybody stay safe, stay healthy, and I hope to see you here next week. Okay.
Wait, click on the link I
Okay.
sent. I want to see if it's
where's
the
the link at? If
It's in the
it's under
discussions.
discussions, and is it on Carburetor?
Yeah.
All right. All right. Let's check this out. Okay, so this is a round slide carburetor. Oh, interesting. And it is, okay, $80. That's not bad. Yeah. Interesting. Okay, so Nathan, you know what I'm looking for is I want to get a cheap throttle body. So if you get a modern motorcycle, right, they're fuel injected, and they have something that looks like a carburetor like this, but it's got a fuel injector that you plug in the side. I want to get one of those, and I want to adapt it to one of these clone engines.
Huh.
So be on the hunt for that. Thank you so much for sharing with me today. Everybody stay healthy, stay safe, work on whatever you can, and we'll catch you here next week. Okay, guys?
Sound good.
All
I'll
right.
see you guys in
Take
2
Stay
weeks.
take
well.
care, everybody.
What about our group in Tuso's class? You were talking about that.
What we're gonna do with that is I'm gonna set up a time in the fall for your group to meet with me and basically fire up your engines and get credit for your class. We did not
Okay.
have a mechanism to give 4 students credit for the class and nobody else. That just it doesn't work. So I met with the administration at ARC. We went over it, and what we decided to do is in the fall, your group, we're going to do what the school calls a credit by exam. Your exam will basically be firing up your engine. I might also give you a paper test if Mr. Tuso gives me one to share with you, but that'll allow your group to then basically finish that up and get credit for that class in the fall. Okay, so
Okay.
it will count for something.
So we'll just get an incomplete until that happens.
Exactly. But we do have a mechanism. But we couldn't set it up where we could give it to you this semester and only have 4 students get credit. The school didn't have a mechanism to do that. So
Yeah, that doesn't sound that fair just because we were working extremely faster than everyone else.
all right. So credit by exam in the fall. We'll make it happen. All right,
Okay.
everybody, you guys take care. And
Have a nice
I look
spring break,
forward to
Mr.
seeing you
French.
guys next week. Okay. Bye for now.
Bye bye.
Have fun on spring break.
Yep. Spring break, everybody.